All right, section C of chapter 9 is fairly short and actually it just has one slide. And this gives us one rule with kind of four variations or four corollaries, as it were. The change of quantifier rule. Now, this rule is a set of four logical equivalences, and they let us remove or introduce negation signs and change the quantifier of quantified statements. Now, you should think of these like replacement rules because you can apply them to just a part of a line as well as to an entire line. And I also like this rule because even though it seems like, wait, there's four different equivalences and this is so confusing, it's quantifiers. Actually, if you just think about them and say them out loud, they're so intuitive and obvious that you really don't even have to memorize it. Just use your common sense, as it were. I mean, memorize them if you have to. But think about what this is saying. All right, look at line 1 here. It's saying that for all x, s is x. In other words, all x's are s. That is logically equivalent to saying it's not the case that there is something that's not s. In other words, if everything is s, then there isn't a single thing that's not s. So you can go back and forth between these two sides of the line. If you've got this, if you've got some statement that says it's false that for some x, x is s, you can switch that for all x, x is s. All right, think about the next one. This says if it's false that all x are s, then it's true that there's some x that's not s, and vice versa. If there's something that's not s, then it's false that all s are x. Look at line 3. If it's true that some x is s, then it's false that for all x, they're not s. In other words, if something is s, then it's not true that all the s's are not s. And then finally, if it's false that some x is s, then it's true that for all x, they are not s. And if it's true that no s is x, then it's false that there is some x that is s. Now, as I say those out loud, you probably got confused, or maybe you did. But if you stare at those and think about what they're saying, and I think it should become intuitive to you. The real trick is to figure out when am I going to use these rules and how are they going to be useful to me as I do proofs? And the answer is this. You're probably going to be using the change of quantifier rule at the beginning of a proof when you're dealing with these quantified premises, and at the end of a proof when you're kind of reintroducing quantified conclusions after you've been applying your implication and replacement rules. So let's look at an example here. Okay, so we got this proof. It says for some x, if it's true that some x is g, then all x's are f. Premise 2, either a is g, or for all x, x is not h. So in other words, either a is g, or nothing is h. All right, and then line 3, we've got if it's false that for all either it's false that all x are f, or some x is not f. And what we're trying to get to is it's false that b is h. All right, I just kind of said a lot out loud, but let's stare at this for a second and think about what they are actually. Now, as always, we want to start with our conclusion and think about how am I going to get that? So the conclusion is it's false that b is h. Now, where do you see the predicate h occurring elsewhere in this proof? Oh, right, here it is on line 2. It's part of a disjunction. It says either a is g or everything is not h. Now, I can tell already that's what I want. If I could prove that this is true, that everything is not h, then I could prove that b is not h. So my basic strategy is going to be I want to basically be able to do a disjunctive syllogism on 2 in order to get this disjunct. I want to prove that for all x, they're not h, and then I can use universal instantiation to get this final conclusion. Now, that means that I'm going to have to prove that GA is false. Now, how am I going to do that? Well, where else do I see G predicate? In premise 1 here. Premise 1 says, for all x, I'm sorry, for some x, x is g. If it's true that for some x is g, then for all x, they're f. Now, if I could prove that it was false that some x is g, then it would also be false. I could prove that certainly a is not g. So basically, that's going to be my strategy. I want to be able to prove that's false. How am I going to do that? Modus tollens will do it for me. But if I want to do modus tollens on line 1, then I want to be able to prove that the consequent here is false, that it's false that for all x, x is f. Well, how am I going to do that? Check out line 3. Again, there's another disjunction, and one of the disjuncts is it's false that for all x, x is f. So how can I prove that that's true? Well, think about this. What's the other disjunct? Some x is not f. Now, apply your change of quantifier rule. Your change of quantifier rule says that this, some x is not f, is logically equivalent to this. For all x, I'm sorry, it's not the case that for all x, they're f. Now, I can apply change of quantifier rule to this part of line 3. And you know what I get? Hold on. Here's what I get. Either it's not the case for all x, f of x, or the same thing. Now, why would I want to do that? Because I can now apply a rule to this line. There's a rule, you know, that says if either P or P is true, I'm sorry, then P is true. What rule is that? Tautology. By tautology, now I've got, it's not the case that for all x, x is f. And now I can do that modus tollens on line 1, which is what I wanted to do. And now I get it's false that for all x, I'm sorry, it's false that for some x, x is g. And that lets me make the next move here, because I can again apply change of quantifier and say, that means it's true that for all x, x is not g. And now I can do universal instantiation and say, therefore, specifically at A, it's not G. And now I can run that disjunctive syllogism, right? And I've got, so it's false that for all, I'm sorry, it's true that for all x, it's not H, and therefore it's true specifically by universal instantiation of B that it's not H. So change of quantifier did some crucial work for us right here at line 4 and then at line 7. Oftentimes what you're going to see is that you'll be using change of quantifier and then instantiation at the beginning of a proof. And then at the end of a proof, you'll be doing like change of quantifier and generalization to get to a quantified conclusion. This worked a little bit differently, but that's often the pattern.